In this video, I'm going to talk about multiple regression in R. To get started, I'm going to go ahead and load the tidyverse, and I'm going to update the theme to that cleaner theme minimal. Then I'm going to simulate the data set. Again, I'll have 51 observations. My model here has two terms, so notice it's y equals beta naught plus beta 1 x1 plus beta 2 x2. So I need to define what those are. So beta naught's 3, beta 1 is negative 2, and beta 2 is 3. And sigma is 0.75. That's going to be the standard deviation on the error term. The true f, this is the one that I want to recover. It looks like that, beta naught plus beta 1 x1 plus beta 2 x2. And then here's how I generate my data set. My x1 and x2 are going to be independent of one another, and they're both going to be generated from a uniform distribution. And my y is going to be f of x1, x2 plus the normal noise. And if we look at the data set looks like this. So x1, x2, and y. From here, what we would probably do is we would look at the pairs plots. So this comes from the ggally package. I can run ggally, ggpairs, and I get this nice pairs plot. Notice that x1 and x2, here's the scatter plot of those two. Those are clearly uncorrelated. And then if I look at the correlation between x1 and y, there's this negative association there. And between x2 and y, there's a positive association there. And that's exactly what we would have expected because we know actually what those true parameter values are. Okay. In practice, of course, we would not know that, but we would actually see this in the graphics themselves. I'll show you something else here, and this is really neat. First, I'll show you the ggplot. So these become a little bit more challenging to see these with ggplot because ggplot only gives you 2 spatial dimensions. You can't see in 3 spatial dimensions. Nevertheless, you can add other aesthetics to actually see the data. So here we're sizing the points by y. And you'll notice that roughly as you go from the top left to the bottom right, the points get smaller. Now there is a package to do some visualization in 3 dimensions in R. It's called Plotly. And if I run Plotly, the syntax looks like this. Data, I give it x, y, and z aesthetics, and then I put the tildes in front of them. Then I say add markers. These are the actual points. The color is black and the size is 100. Okay. If I run this, I get this plot right here. I can click zoom to make it a little bit larger. Make this window a little bit bigger here. And we actually have an interactive graphic here. So if all the model assumptions of linear regression are true, the points should lie on a plane, if in fact that's the model that we're looking at. The points should lie on a plane in 3 dimensions, okay? And they should fall off of that plane just a little bit. So there's no way that I can rotate this so all those points fall on a line, but they should roughly fall on a line. That would essentially be us looking at the plane kind of head on where it would be infinitely thin, okay? So that's the exploratory data analysis side. On the modeling side, the syntax is almost identical to what we've seen previously. So we would say mod is lm y tilde. Before we had x or poly x. Now it's x1 plus x2. That's the model specification for multiple regression. Data is data. Okay. I'll run this and I can type in mod, and there I see the coefficients there. About 3, about -2, about 3. Those are close to the parameter values that we know. Of course, we can do everything else as well. So I could say coef mod to get the coefficients, resid mod to get the residuals for each of the points, or I can type in fitted values of the model, mod, and I get the fitted values. Those are the y hats, okay? I can also do something like summary mod, and I can see each of the estimates there, their standard errors and associated p-values. I can see the RMSE right here, or I could have computed it the other way like we have done in previous videos. The last thing that I'll show you is prediction. So prediction, and it's going to work in exactly the same way too, but I need a new data set, right? So new data, this is the data that I'm going to predict on. It's a tibble, and it will have x1 and x2 in it, but it won't have y in it. So let's say x1 is 1 to 2, and x2 is, let's say, -2 to -1. So if I look at that, it looks like this, and that's what I want to predict on. So my prediction will follow the same scheme as before. So I'll take in mod piped into predict, and then new data. Just like this. Those are those y values. So if I wanted to do this in a slightly different way, a little bit of a tidier way, maybe I'd say new data piped into mutate. Y hat is predict mod dot. and then that would give me x1, x2, and then I would have my predicted column there as well. Actually, one last thing I want to show you is interactions. So how do you do interactions in R? So I'm going to make my section here. Maybe I'll clean this up. For interactions, we essentially do the exact same thing as our ordinary multiple linear regression model, but we change the formula just a little bit. And the formula specification you may think would do something like this: x1 plus x2 plus x1 times x2. And in fact, that'll work. So if we run this and we type in mod, we get exactly what we want. But actually, there's a slightly different syntax that makes this a little bit easier. I could say just x1 tilde x1 times x2, and that will give me precisely the same model. And the reason is that interactions in R are actually specified in either of two ways. Either the interaction is specified x1 colon x2, and I'll just get rid of the mod here to show you what this looks like. If I specify x1 colon x2, that literally just goes to those two columns and multiplies them together to give you a new column, and then uses that new column in a simple linear regression context. Or alternatively, I could have actually wrapped these up in I like this, x1 times x2. That would give me precisely the same model. So ordinarily, when we want interactions, we will use x1 times x2. You should have noticed, by the way, when I did that, it also added those linear terms in. So x1 times x2 is both x1, x2, but it also has the x1 and x2 terms in there. Almost always when you have interaction models, models that have something like x1 and x2, you will also want their so-called first order effects, where the linear terms are in there as well. So that is multiple regression in R.